with further ado, we will jump right into scaled chaos engineering with automation and AI. So, who are we? I'm just your host. I'm less important, but Phil is very important. Phil has been with us since almost the beginning of Gremlin. Phil, do you want to talk a little bit about yourself and kind of what you've led over the years?
Hey everyone. Yeah, so I am a principal engineer here at Gremlin. I've done all sorts of stuff here, but one of my favorite contributions is working on the software that introduces failure onto the machines. So things like driving up latency and making CPU resources starved. I've played a hand in that as well as our backend systems and our SaaS product. And you're right, I've been at Gremlin for quite a while. It's been a great experience being able to be a part of a team that's grown from a small company to where we are today.
That's awesome. That's also the injection part of the fault injection, which is like half the product.
Indeed.
So, what are we going to talk about today? Today, we're going to talk about how, when you take chaos engineering, what are kind of the pitfalls that you run into when you try to scale it? How do you actually go to scale beyond a single team? And then we're going to look at some of our best practices, how we actually use chaos engineering and the techniques we use to get five nines uptime. And then Phil's going to go a little demo to show how all of the things we talk about can actually be applied. But first, let's actually just kind of remind why we're here. Why are we testing? Phil, what's our goal with all of this?
Right. Yeah. Why are we here? Why chaos engineering? Well, to set the scene a little bit, I'm sure most of y'all on here would agree that our systems are pretty complex, right? Even small software modules that work predictably in a vacuum can behave very unpredictably at scale, especially in concert within a larger system, much like the butterfly effect. Those of you that are in large organizations probably see the rate at which software changes is quite fast, and the infrastructure on which those systems run, there's so many machines that the likelihood of any one of those machines failing approaches a statistical certainty because hardware eventually fails, right? So chaos engineering is about building confidence in our systems in the face of those unpredictable conditions. It's also about building confidence in your team to get exposure to common failures that happen in production all of the time so that you know how your system behaves in those situations, so that your on-call engineers have the exposure needed to act in emergency situations in production, so that your developers are thinking about reliability as they're writing their code, finding issues in development where it's cheaper to fix problems as opposed to in production. And so that your team can work cohesively together to all make the right decisions and the right trade-offs in the face of these really hard conditions that we're in. Because it is a team effort. Everyone that touches the system should be thinking about reliability to make sure that the unpredictable, turbulent nature of our systems doesn't stop our business.
Oh, that's fantastic. So here's my question then. That sounds like we need to scale to the whole team. And I think that's why we're here. So what do we run into? We've had a lot of our customers and a lot of people we've seen who are just, they use chaos engineering great on a small team, single developers that are really good experts get great results, but then they have trouble scaling. So what kind of troubles can people run into when they try to roll it out to the rest of the organization?
Right. And ultimately, there's work that's involved. And like with adopting anything in your organization, you want to have standards across the board. And with chaos engineering, it's no different, right? Having a repeatable set of steps that you can follow and having repeatable tests that you can run to enforce a standard across the board is the name of the game. And so by getting your teams all involved, getting everybody to adhere to a similar standard, but also in the same mindset, in the same line of thinking around not only caring about reliability, but being curious about how systems behave even in unexpected conditions and less than ideal situations. Because when we're all on that same page and we're all thinking about it, the unpredictable nature of these systems becomes more manageable.
Right.
And it,
So
yeah.
yeah, where does that break down as we're trying to bring more teams on? Are there specific spots?
Right. So as it relates to, actually doing the work of scaling this out into your organization, you really can break this down into a few pieces, right? The first step of this is just getting started, right? What tests, how do I even run tests? What tools should I use? How do I set it up? But then also, how do I test meaningfully, but also safely in a way that I can actually get data points from my system in a way that's going to be repetitive, a way that my team can follow, and a way that we can do it sustainably. And then, of course, the reason that we're all doing this so that we can learn, how do I actually get meaning from my tests? How do I understand what a test is telling me about my system, what it means for production, and then, of course, how do I prioritize and get to the fixes that are necessary?
Great. So let's dig into each of these. I think let's look at onboarding. What can teams do to bring on more teams easily? If you're a centrally managed expert and you're a performance engineer, you're an SRE, you're a head of engineering, you're trying to get more teams on board. How do you how do you get them on board?
Right. So just getting started, right? And figuring out what do I need to do to actually get started? And really it starts with your observability, with your monitors, the things that are telling you that your system is healthy. I think an important thing to take away from anything about chaos engineering and failure testing is it is a test against your monitoring systems as much as it is about your software itself, the systems themselves. Making sure that your alerts are telling you when there's a real problem and they aren't telling you about problems that don't exist. And so, a part of that is also figuring out what are the signals I should care about when it comes to learning about my system's reliability. And it's important to focus on the things that actually impact users. So things like error rates and request latency and request rates themselves, making sure requests aren't at zero, that actually requests are coming into my system. These are all really important characteristics that are measuring what your users perceive and ultimately the reliability of your system and why it's important to care about this in the first place. Now, in Gremlin, we integrate with observability. And so that looks like taking the monitors that you already use in production to verify system health, importing them into Gremlin, and treating them as a health check. We call these health checks to say, is the system healthy or is it not healthy? And so by importing those observability tools into Gremlin, you want to start looking at those not only to define a healthy baseline, but also then to catch when systems are behaving poorly as a result of a test. Now, it's important to also say that, because these are tests on your monitors as well, it's really important that when you're running tests in staging, that you're using the same monitoring to measure the system health of staging as production. For those of you who might not be quite there yet, you should know that Gremlin also offers tooling to look at some metrics on your behalf, such as CloudWatch. If you have load balancers in AWS, we can create what we call intelligent health checks for you based on simply the CloudWatch metrics of your existing system. So pull in your observability, get some health checks set up. That is really step number one. And then you're really ready to start testing. And maybe a quick call out here to the differences in testing. Of course, we have validation tests like unit tests, things of given an expected input, I expect a certain output, right? But any good AI engineer will tell you that that's really only a part of the story, that a testing mindset really requires some amount of curiosity and assumption challenging, the ability to ask, well, what if X were to happen? And so there really are multiple ways of thinking about testing here, but because we're talking about getting started and how you get exposed, how you expose your teams to something that's new, really starting with validation testing. And when it comes to failure testing, thinking of a test suite of common failure modes that I can run against all of my services to get a good baseline reliability gut check is a great place to start. And so in Gremlin, what does that look like? Well, we have a recommended test suite. It's a collection of tests that cover all sorts of problems that are common in production, from redundancy issues, like what happens if a host or a zone goes down, to compute starvation issues, like what happens to my application when memory is low? Does it scale up? Does it scale back down, importantly? And things like dependencies behaving poorly. Are they unreachable? Are they just slow? This collection covers a ton of ground. And, as a callback to these two types of testing, sometimes validation testing really spurs that curiosity to say, well, if this validation test is telling me something about my system, what other tests might I want to run to learn something else that puts you into exploratory mode? So starting with these common test suites can lead you down a whole fruitful path of discovering more.
Great. And what about misconfigurations? I know that's a common thing where like
Right. Now,
that's
even before you get started with tests, there are some pieces in Gremlin that can point out problems waiting to happen, if you will. We call these detected risks in Gremlin, and they are often, as Gavin points out, misconfigurations. You can think of this as like a linter for your reliability posture. Things like making sure you have memory limits defined on your pods, or making sure your auto scaling groups have appropriate min and max sizing and other misconfigurations. Things that are probably going to be problems eventually that you can verify through reliability testing, but that you can get a signal even before you start testing.
that's great. So this will all help people kind of have a ready-made thing that they can just roll out to new teams, but then they can build on it as they go. Right?
Exactly.
Like you can add, yeah, that's great. So then when it comes to actually testing, how do you enable, you got these engineering teams. They're not testing expert. I mean, they do normal Q testing, but they're not performance engineers or SREs. They haven't spent all the time in the trenches learning chaos engineering. How
Right.
do we get them actually putting in the time to test?
Right. And, really to get value out of testing, you really need to do it regularly. Of course, just like any other testing, right? Why do we do unit tests and integration tests on a regular automated basis? Well, it's because software changes and doing testing needs to be a repeatable process. And on top of that, when it comes to, again, a call out to the unpredictable nature of large systems at scale, sometimes the system doesn't always behave the same way when given, the same set of conditions. These things can be unpredictable. So running tests very regularly to create many opportunities to find sometimes rare failures is really what's needed. And that can be, of course, a labor-intensive process. Running all of these tests manually is not something that scales across your organization. It's not sustainable to do. And that's exactly why we recommend running these things on a schedule and why we have features in Gremlin that allow you to schedule this test suite of common failures on a repetitive basis so that you can run them every week as close to continuously, even ideally, so that you create many opportunities to learn from failure.
So when you schedule those, you don't do you stack them up and run all of them at once, or do you spread it out? What's the best approach with that?
You definitely want to spread them out, right? You don't want to introduce unrealistic conditions, certainly, of all sorts of disparate failures happening at a given time. That could make for a good exploratory test. But when it comes to regular validation tests, you do want consistency and you want the ability to really understand what happens from a given failure. And so you really should stagger them across many services, for example. So perhaps every week you want to get all of your services tested. Well, maybe that means on the first part of Monday, you're testing one service, and the second part of Monday, you're testing another. And then on Tuesday, so on and so forth. You really should stagger them, and Gremlin provides exactly that. You can schedule specific windows for your services, and in doing so, you avoid common problems like running too many tests together, in which not only can that be overwhelming, but also hard to get true understanding of what a test might be.
Right, because realistically, it's not often that all of a sudden everything latency everything's going to have a latency, and unless it's Monday, the entirety of EC2 and DynamoDB won't go down at the same time.
Right.
Normally, that doesn't happen.
And normally it doesn't happen. And when it does happen, usually there are lots of things at play. And so certainly, tests that involve many failures are valid tests to run. But also there are many, again, common failures that do not involve all of those things happening. As complex as our systems are, sometimes it only takes a single failure, a single host going down, or a single dependency behaving slowly for that to turn into larger issues. And those are the issues that are worth spending time and fixing before you get too far out there with crazy tests like that.
Ah, that's great. And then what about processes? Because how do you, like you said, it's manual, it takes time to run these tests. How do you minimize the last thing any engineer wants is, oh, I've got one more thing to do. They have enough on their plate.
Right, exactly. Like you have to run these tests in an automated way. And so you don't have to worry about, running these manually and spending a lot of time there. But as you're accruing these data points, right, and learning from your observability and running these tests and accruing these data points about your system's health, you do ultimately have to review them, right? That's the reason that we're doing this. We're trying to learn from our system. And so rather than creating a brand new, you know, ceremony that you have to follow, really, we find that, attaching into an existing process, chances are you have an incident review or an on-call rotation, somewhere that's relevant to talking about the reliability of your system, that is the best fit for reviewing tests like this. You can, much more easily attribute things like test failures around problems with dependencies or error rate spikes in the context of talking about a production issue because that's where it's relevant. And that's where you're going to ensure that you're going to do it on a regular basis by attaching into an important ceremony like an incident review.
Awesome. All right, so then let's actually look at the results. So what does it look like? How do we speed up getting the results? Like what does it look
Right,
like normal like if you get it back, great. The test failed. Now what?
right, right. Yes, you're starting to trust your monitoring. You're running lots of tests. You're getting good data points. and and your health checks are telling you whether your system is healthy or unhealthy. As a reminder, again, sometimes these are testing your monitors just as they are testing your software systems. So really, you do as you're reviewing, you need to be considering all of those things as data points when you're interpreting test results. So, th this is where it's not just about how your test fail, or I'm sorry, it's not just whether your test fails, whether your system is healthy or not healthy, but it's about how the test failed that you really can understand something about a system. And that's really where the rubber meets the road here, right? You have monitors that are measuring different qualities of the health of your system, and you're running lots of different tests to give you data points. And now you've found a test that has failed, and you have to understand what your monitoring is telling you. And so begins the hard work of connecting the dots, right? Maybe you saw a spike in errors after introducing a small amount of latency into a dependency. And how do you go about identifying the cause of that issue and get on the path to fixing? At the scale of your organization, this is also a labor-intensive process. There are ways in which your tools and your experience can help you connect those dots. And, as another call out back to, a part of this practice is building that exposure so that you have confidence and you have experience in your system so that you know what's going on. As
But
you
part of
get,
that is you need the actual engineering teams involved, right? If you're just a central testing group and you find that latency error, you you might not know the product, the service well enough,
well,
right, to actually track it down.
absolutely, yes. And that does get better with exposure, of course, right? The more you're exposed to failures, the more you develop instincts and skills for connecting dots, connecting cause with effect, sometimes causes, because there can be multiple causes sometimes. But, that is a real problem. And at Gremlin, that's something we've been trying to solve, not only for ourselves, because we are users of Gremlin and while we live and breathe reliability, everybody has different skill sets here at Gremlin, even though we expect all of our engineers to be on call. And so that's why we've developed, features that we're putting under this umbrella term reliability intelligence. That's all about making observations more clear that otherwise require a lot of digging in order to get to the bottom of things. So, for example, being able to learn about your monitoring that you give us, that you integrate with us, and our knowledge of the tests that get introduced, and our awareness of events that happen along the way through the tests, we can take all of that information and start to connect the dots from a test result and provide you common problems that get associated with those dots when they're connected and reveal common solutions. So that if nothing else, it's a jumping off point where you can say, This is a common situation which all of these factors occur, and this is where you should start looking to see maybe an increase of latency leading to errors happens to be highly relevant to timeout conditions, and you should maybe look at tuning your timeouts to for this particular dependency because this is likely what's going on.
And will it just give like one the most likely result, or do we see multiple suggestions? Because, like you say, latency introduced could be timeouts, could be something else.
Right. Exactly. There's many, and this is in part why things can be so labor intensive, is there can sometimes be many alleys to go and follow through. And so no, there's not always one answer to what particular test might reveal. There could be many. And in, and there's another good call out here, which is you always want to think about these things through the lens of production as well, right? Because not every issue is going to be something that you absolutely need to fix because some of it either could be require an extreme amount of, you know, dollar investment to, achieve minimal returns. And so it is always important to think about these test failures through the lens of production. Are my users minorly inconvenienced? Are they unable to log in or check out? And then, yes, and then exploring the different avenues that could lead to a potential reason why a problem has occurred.
And that seems like that would help with prioritizing which ones, like you say, the checkout one, that seems important to fix,
Yeah.
but something that's more internal or back end, that might be less important, right?
Exactly. Exactly. And so in related to that, as you're thinking about production, that's again the perfect time to be thinking about these test results in an existing process around your production's health, right? Going back to that incident review or that on-call process, at the time in which you're talking about production already and its potential impact based on a given dependency or a given test, that's where these tests and their results are hugely important because you can say, oh, we ran this test this week and it's telling us something about production that may lead to something you should know about when this given monitor goes off.
Right? So this is all very good. Like, this is great theory. How does it work in practice? How do we do it? Because I
Right.
know we do.
Exactly. So at Gremlin, we have an on-call rotation, like I'm sure a lot of you have. That on-call rotation lasts a week, and every engineer goes in and out of that rotation. They are the first person to be notified when an alert goes off in production. So they're responsible for understanding what that alert means, what it means in production, how is it an emergency, and who do I need to bring in to make sure we stop the ongoing problem. In addition to that responsibility, they're also responsible for keeping an eye on all of our scheduled tests that we are running constantly. We run through the test of every given service every week, and of course, we stagger them as we talked about previously. Keeping an eye on those tests, making sure things are running as expected and that no new test results are coming out that need our immediate attention. And sometimes it's about running some of those exploratory tests. Can I try to reproduce an incident that we saw last week in production? Can I go and try to bring a part of my database down in staging, for example, to see if I can reproduce the same conditions and learn something about what's going on? And it's all of that work that happens on that weekly cadence alongside the responsibilities of keeping production up that we then do a regular review of what happened. We call this our on-call handoff as we go through a week of on-call and we're handing off our on-call responsibilities to the next engineer who's rotating in. It's an opportunity for not only the two engineers involved in that handoff, but for the entire team to learn something about what happened in production that week. And tapping into that existing process, it's the perfect opportunity to talk about the tests that were run and what that tells us about our system. Something we haven't talked about yet that we'll see in the demo is this notion of a score. As we're accruing these data points and running tests on a regular basis, it's contributing to a score that gives us an aggregate idea of the reliability of our systems. Now it's
So
the
kind of like a metric of the reliability. It's not just, hey, we didn't have outages. It's actually where we are,
yes.
how reliable we are now.
It's much more nuanced than, hey, we didn't have outages, and it can be broken down into categories like redundancy and scalability. But in many ways, it's not about the absolute value of the score, which can be important for comparisons and others, but even more importantly, it's the changes in that score that serve as really good conversation starters for what has happened throughout the week that we need to go dig into. Did we introduce a new dependency that has not yet been tested and that is reflected in our score? Are we running an untested dependency in production, for example? Or has an existing dependency all of a sudden started behaving differently? When we've introduced some latency, a service now all of a sudden starts to behave a lot more slowly than it did before. All of these things are real conversations that we've gotten into simply by having the starting point of reviewing the tests that have happened and asking ourselves questions, being curious around what has happened to really learn something about our reliability. And by doing it on an ongoing basis and rotating engineers and getting that exposure, even when you're not on call that week, you're learning something about the system and bringing that back to the code you go and write.
That's great. Yeah, and you mentioned this, like none of these are new processes. We obviously had engineering operations calls before. We had on call like that. Everyone has that. And we just kind of integrated into what was already there, right?
Exactly. We're leaning on the automation so that we don't need to run these ourselves. And so we're leaning on the Gremlin platform running the test for us. And then we found an opportunity from an existing process we had to then incorporate those results in. And in many ways, that's some of the most interesting parts of our on-call, talking about the tests and the potential problems that they can create, more so than things that may have happened in production, because oftentimes we've learned about it already through some of our testing.
Right. And there's a bit of a segue, but I do remember there was some story about the reliability intelligence really enabling this, our own team, where we had a front end engineer who saw an issue and because of the recommendations was able to just loop in the exact engineer who wasn't an expertise in the area and actually able to address the issue really quickly. So that kind of I think that was the situation. But yeah, that kind of builds on itself as we go through this. And so I think you're talking about all engineers get a little bit more exposure to what's
Exactly.
needed.
That's exactly right. You don't need to be an expert to ask good questions. And sometimes you just need a little bit of a jumping off point to start asking those questions, put your curious hat on, and start digging into something. And then, of course, as that curiosity builds and you bring in people who are subject matter experts, you then together come to some important conclusion. And yes, we've seen that multiple times with many parts of our system, from detected risks, pointing out potential issues, to, yeah, the analysis that reliability intelligence performs of pointing out common patterns that should be followed that could explain why a particular test failed.
Right? So I think maybe it's time to see it in action.
Yes.
So Phil, I'm going to let you take over and
Cool.
you can do a little bit of sharing. And while he's bringing that up, we already have one question, but yes, please drop your questions in the Q&A or the chat. We will have a Q&A section right after the demo.
Okay, so let's see. Did I get that? Can you see my Gremlin page here?
Yes, we can. Looks great.
Perfect. All right. So, by the way, all of these pages I'm going to show you, these are actual pages from Gremlin of our own usage of Gremlin, our own services, our own health checks, all of that stuff. I have changed some identifiers on these pages, as the engineers might happen to notice, for anonymity reasons, but these are otherwise real components in our system. And as we talked about in the slides here, the place you need to start with is your observability. And so this is one of our health checks. This is the way you import your monitoring tools into Gremlin. You create a health check. In this case, it's pointing to one of our Datadog monitors that is measuring the error rate of one of our systems. Now, when we run tests, Gremlin is looking at these imported monitors. The logic for what determines the service's health is all tracked in Datadog for this particular example. But we pull from Datadog to see whether the monitor is triggered, and that's giving us a signal on a service's health. It's also important to categorize these health checks. In many cases, Gremlin will automatically categorize a monitor for you as you import it, but you can give a category yourself. And this is another plug to, think about the qualities of your service that are going to impact users, because those are the important things to think about for measuring a service's health. Errors, latency, requests, these are all really important characteristics of a system's health. Really having a health check for all three of those is what I would recommend. So you not only know when a service fails a test, but how it fails. So we have these monitors imported. Let's talk about the next piece we talked about, which is the test suite. This is Gremlin's recommended test suite. This is the default test suite that every user in Gremlin starts with as they start creating services. You, of course, can create your own as you get curious and find those additional tests that are worth testing for your system. But this is the place to start. It covers a ton of ground. These are likely problems that you have already seen in production, whether it may be having enough redundancy so that if an availability zone goes down, your business can resume. Or how about a single host going down, making sure that that has minimal impact on your system? Because again, machines will ultimately fail. You can expect that to happen. Or how about scalability of compute resources, right? How does your application behave when memory or CPU is low? Going back to scaling up and scaling down, can it meet the demand of your users on your service, even when resources are low? And then I think usually these are certainly my favorite. I think there are a lot of people's favorites. The dependency tests. We can check, for example, if you're going to have a TLS certificate that's going to expire in the future. What happens when a dependency is unreachable? You make a request to it, but you don't get a response back. Or how about if it's just a little bit slow? Going back to that butterfly effect analogy, what happens when just a tiny amount of latency is injected into every single one of your network calls to a dependency? How might that add up to becoming a problem?
And when you look at these are tested for a service, like it's a checkout service, does it run just how do we select the dependencies? Does it run all the dependencies? Like we see one test here, but it's not just one test. It actually runs it on multiple dependencies, right?
Yes, yes, that is a important call out there. Each of these tests, of course, has its own category. When it comes to the dependency tests, each one of these tests is run against every one of your dependencies. And so in that fashion, we're not just saying what happens when none of your dependencies are reachable. Again, maybe a good exploratory test to go and do, but not always the best test to start with. How about starting with what about just when one of your dependencies is unreachable? Like your cache or your database, or maybe S3, where you're pulling your assets. And so, in that fashion, you're doing a thorough, exhaustive test of all of your dependencies in a controlled manner. And then, when coupled with scheduling, makes that an actual sustainable practice.
Right. I remember there's an example that Sam, our CTO, mentioned about a Redis cache where it was just they introduced a little bit of latency and the failover to the main database didn't trigger and caused a brownout. And it was supposed to happen. And it was just a, tweak of the timeout before the failover. But that was discovered through a latency dependency test. And so kind of running those will catch things like that.
Exactly. And yes, we'll see a little bit of that here. I'm going to move over to this is one of our services. And here you'll get a sense of one, we have the reliability score and we see the components that make it up. But this is our scheduling at work. This is those data points getting accrued. You can see a lot is going on here in the test results that we've accrued here. You can see some passing, you can see some failing. And here's our dependencies right here. You can see all of those tests being run against all of our dependencies. And as we mentioned before, going into every single one of these results in a manual fashion, let alone running them, but also reviewing them, can be quite labor intensive. And this is where we've tried to separate signal from noise so that as you're looking at this services health view, you're also seeing some signals pop out as things that are worth looking into. For example, here we have two. We have one related to this host test here that is showing a diagnosis has been found, as well as one for Redis. Before I get there, I also want to say that these dependencies here, this is something that we automatically can discover for you. Based on the activity of your service, we will find the dependencies that you're talking to. It's actually one of my favorite features because it challenges our assumptions all the time. We're thinking we're talking to a dependency in one region, and it turns out we're actually going to US East where we shouldn't be going because of a misconfiguration on our end. So learning from just the dependencies we discover itself is also really useful. But let's start looking into some of this intelligence here. So
Before we do that, I do want to ask a question. I don't know about the rest of everyone here, but I have some academic PTSD seeing the red marks and those of us who are overachievers going, "Oh, it's not an A." But this isn't a grade, right? This is not like we need to get all green and get 100%, otherwise we have disappointed everyone. This is more about just a status, and is it more about a status and discovery?
it's an excellent question. And you're absolutely right. This is not a grade, and not every test needs to pass, right? Our services are, first of all, running in hostile conditions where things can fail quite frequently, but also not all of our tests have the same production importance when you think about them, right? On top of that, I'm sure there are single points of failure among some of your systems. Maybe it's a database, or maybe it's a critical piece of infrastructure you rely on from a cloud provider. Not all of these can be fixed without a tremendous amount of investment from your business. And some of those fixes aren't worth doing, but it doesn't mean that you shouldn't test them, because you should understand how your services behave, even on a database that you have no redundancy on, and you know that that would be the case. You still need to understand how those failures manifest, because if that were to happen in production, you should understand what you should do about it in an emergency situation. You should understand how it might manifest so that you can determine whether it's actually happening in production.
And that
Test,
might actually speed up your MTTR when you actually have, you know that this is a risk, you've accepted that this is a risk. So when it
yeah,
happens, you know how to fix it faster.
exactly. Think about it like a fire drill, right? We hope that fires don't happen, but we need to be prepared for when they do. And so walking through those like a fire drill absolutely leads to more effective results when emergencies do happen.
That's good. It's good to know that that red failure doesn't mean we've disappointed our parents. So let's move on to the reliability and intelligence.
Right, right. So we got a couple here, and depending on timing here, we can talk about two of these. So let's start with Redis. Here we have a real test result that was running a latency test against our Redis dependency. It introduced a pretty minor amount of latency, 100 milliseconds. And what you can glean from this test right away is that we saw one of our health checks failed. And in fact, this is one of our intelligent health checks. We actually run both. We import our Datadog monitors, but we also let Gremlin generate health checks based on CloudWatch metric data of our load balancers. And that's measuring what users see. And so in this instance, we introduced a small amount of latency, and our health check detected an unreasonable amount of latency seen by users as a result. And so this is where the connecting the dots comes in. And when you look at the reliability intelligence diagnosis, the dots that it's connecting, well, it knows about the latency test, and it knows that the health check that triggered was latency. And it looks for common reasons that a small amount of latency being introduced can lead to a much larger amount of latency seen by users. And it came up with a couple of things. One of them is something that could be present in our system, and this has to do with request batching, or folks might know this as the N+1 query problem, where when you introduce a small amount of latency, you're going to eat the cost of that latency every time you make a network request. So even though one network request, oh, an extra 100 milliseconds, that's no big deal. But what happens when I need to make two, three, four, 10, 100 of those requests in sequence? Well, all of a sudden that latency starts to add up. And so a common problem that can be seen in a lot of systems is this N+1 query, when latency is added, really turns into a real problem. And that's exactly what this first suggestion is here, is you should look at the potential to batch multiple operations to this dependency so that you don't eat that latency cost every single time. And that cost is much smaller. By the way, we have links to our documentation about these problems and some examples on how to fix them so that this is even more than just a call out, but a good jumping off point so that even if you're not an expert in this particular system, you can start to ask good questions and start to poke around and think about, well, is this suggestion relevant to me? Is it relevant to my production use case? And is it something that I should look at and potential to fix? But as Gavin rightly pointed out, not all that, sometimes adding latency, well, we have no point, or sorry, we have no choice but to pass that latency on to the end user if it's a critical dependency that must be accessed. And we can't batch up anymore. And ultimately, we need to eat that latency cost. Sometimes that is the answer. And so, sometimes as we call out here in this suggestion, sometimes it's a single point of failure that you have to acknowledge within your system. And it doesn't mean it's not a test worth running. In fact, this helps you understand the reliability posture of your system, where particular failures might exist and what the risk of that maybe is, so that you can focus on that risk and you're educated about it.
Great. Now, you mentioned the second one. According to our schedule, we're supposed to jump to Q&A. Can you go to the second one really, really fast, and then we can jump to
Um,
the Q&A?
yeah, just quickly, here's another look. This is not a dependency one. This is what it looks like for a host failure. In a similar vein, we are connecting dots. So in this case, we terminated a single host of our services. And as a result of that single host termination, a separate health check went off. Going back to understanding how your system fails. In this case, we saw a spike in errors as a result of losing one host. And again, we're connecting dots. We're taking a host failure, we're connecting it with a spike in errors, and we're coming up with what are those common problems that have solutions that you should look into. In one case, it may be that you are running so much on these hosts that the act of shutting one down, the stakes are really high on shutting down those hosts because you are running so much through those hosts that you see lots of errors when that happens. And that would explain what the first suggestion we have here. And the second suggestion follows very similarly, which is you also want to make sure that those hosts are taken out of your production load balancer as quickly as possible so that new requests don't get routed there as well. And that just gives another dimension of not only the different ways in which services can fail, but also the different suggestions that we can find as a result.
And it just gives you a general area. It's not just, hey, the host failed, everything's broken. That's great. It's like, oh no, let's actually start with the load balancers. Because I think that's always the first part, right? Where do I start? Once you start, you can start digging in more.
Exactly. And maybe just to bring it back to our process here, then we take things like this, these two diagnoses that were found, the signal from the rest of our testing, and we bring that to our review. And we look at these suggestions and we talk about the errors that happen. Maybe we dig a little bit further into our monitoring if we need to. And then we use this as next steps. We say, all right, these are things that we need to go investigate now. Can we go run this test again and try to reproduce it maybe in a different way to see if we can understand more? Or should we go follow one of these suggestions and go find the N+1 queries we're making to go and improve our batching? This goes from test result, interpreting, putting it back in the context of production to prioritize which ones are worth fixing and which ones can wait a little bit, and then putting it into action items and next steps.
Right. And this is how we can scale to the extra teams. An engineering team can run these, look at the suggestions, bring them back to the sprint. It's all documented. It's part of the process. There's dashboards. Teams can see it and say, hey, this was flagged. Did we look at it? What did we do?
Exactly.
Great. All right. So it is now I'm going to take back over and let's do some Q&A. So first question that we did have, if I can actually bring it up again. There we go. We've got a question about the weekly tests. Do these weekly tests run on production? And if it runs on staging, how do you simulate user traffic on staging? If it runs on production, how do you guarantee that only a percentage of customers are exposed to the tests, or rather that it doesn't impact customers is really probably the root of that question.
Yeah, absolutely. It's a great one. And I will say the simple answer for the purposes of this, webinar is absolutely you should start in staging. I think the goal would be you ultimately do want to test in production, and everything I showed here is actually tests from production. But they have been done so after lots of consideration before production. So, for example, our single points of failure, we have some, like some critical parts of our database that if you were to shut those down in production today, there would be very big problems for our users. We do not run those on a schedule in production. We do not want to hurt our users on a regular basis there. And so there is a process of, by the time you get to production, finding the ones that are safe to run because you've done the work in staging to trust your monitors that you know from one particular, impact has on your system. Now, that being said, the other good part of that question is, well, by starting and staging, how can I make sure that those tests are realistic by running some amount of load? You absolutely do need to run load alongside your tests so that you can make sure that they're realistic. In fact, one of those three different health check categories I mentioned was requests. For us, that's the measurement of successful requests coming into our system. If that metric is zero, we do not consider that a healthy result, and those tests actually fail as a result. And so the way we do it is we run lots of continuous load through our system, both in terms of the automated tests that we run against staging, as well as the parts of our we have users that are using staging all of the time because they're developing new products, and we have tests that are constantly running that are using staging all the time. In addition to that, lots of our customers use load generation, things like JMeter, Load Runner, Locust, and we do have hooks for those as well. So if you have a load generation test script, things that hit your service or act as users to go check out, and you don't want to run them continuously, which I personally think is a good use of time for continuous testing. But if you want to run those in a more controlled manner, you can hook into Gremlin to say, before tests run, I want to start running some of those load generators so that I actually have real data going in,
And
real requests.
And I know that that does work at a large scale. We actually have this total marketing plug. We have a customer story from Visa where they do that exact same thing. They have a staging environment that they really invested in making have a parity to production. It's financial. They're obviously, with very good reason, hesitant about running on production. So they have invested in a parity environment. They use load generators to try to get it as close to the size and traffic as they can when they run tests. And it's actually helped them find some pretty big issues and prevent them from getting to production. So that there is more of that in the customer story. But yeah, that we definitely have seen that on an enterprise level. So I did have a question that kind of follows into that I noticed while we were looking at the health checks. Phil, let's talk about some of our integrations. I noticed that we had Datadog up there. Is it is there how smoothly do we integrate with that if we're adding a health check? Do we have to do a bunch of like jumping into the code?
No, you don't. So we want to make those as easy as possible because really at the heart of this is health checks are a crucial part of this whole process. And another plug into staging, that includes staging because a part of this is testing your monitors and making sure they behave the way you expect. So you should be running monitors and staging just the same. And so we understand we need to make that easy in order to get users to actually want to import their monitors and really use them and start to trust them when it comes to running Gremlin tests. And so, no, you don't need to write any code to integrate your monitors for things like Datadog and Dynatrace and Grafana and Prometheus. We provide ways to simply provide a link to the monitor, for example, or the monitor's name. You can, search through a dropdown if you're using Datadog, for example. That way, it's as easy as any of the other integrations that we have in Gremlin, so that you don't need to maintain another specific piece so that you can get value out of it.
Fantastic. All right. Are there any other questions that are out there? I know we threw a lot out here, but oh, there we go. When you say that 80% of the most common failure causes are covered in Gremlin's test suite, what does that actually mean in practice? How does that translate across different microservices and tech stacks? Anything to test around changes and releases? As we know, these three-part question. Second part is anything to test around changes and releases? As we know, something changes and breaks the flow, causes an incident. And then three, what are the three top tests that are a quick win? So let's do the first one. Let's talk about the 80% coverage. What does that actually mean in practice?
Yeah, so you know, regardless of the percentage, I think the important takeaway here is that the test suites cover very common failure modes in production, right? So these are things like things that are outside of your application, right? You'll notice that none of the Gremlin recommended test suite talks about the behavior of your application necessarily, but more these are common things that you should expect to happen in production, like abrupt, non-graceful termination of hosts, or network dependencies being slow, or memory being low and CPU being low. These are things that you must anticipate happening in production. And by testing ahead of time, you're creating that exposure to them before they actually happen in production, because they will. Testing these in staging doesn't mean that those problems won't happen in production. It means that you're exposed to them, you've designed for them to an extent in your application and your infrastructure systems and your monitoring, and that you respond and you continue to work in spite of those problems.
It makes sense. And also, incidentally, if you see studies like the New Relic State of Observability, the Splunk, I forget exactly what it's called, but their similar report, when they report the most common causes of downtime, pretty much all of the infrastructure causes are covered by this suite, with the exception of security. Sorry, this does not help your security. But you'll see the rest of the causes are actually the most common causes that they list as the causes of actual outages. You'll see a lot of them are latency, are host failure, are dependency failure, are network failure. They're all just kind of listed in there. So there's actually very much a broad coverage that is kind of backed up by studies from our peers.
And the other piece I'll throw in there too is, we really want to lean on the health of your system as described by your monitoring, right? So it's these common failures, and then it's your monitoring that's evaluating the health of the system. And so in that fashion, it really does focus on what is important for your stack specifically.
Excellent. And then let's jump on to the second part there, which was when you test around changes in releases, we know that that is one of the most common causes is somebody changes something. So how do we test around that?
Right. So testing releases, in the same way, we don't recommend running, say, this full suite of tests every time you make a code change as a gate to production. I think when you think about the scale of how big your systems are, that probably would not be a sustainable process, even if it were automated. But certainly running regular testing, like on a weekly basis, on a daily basis, does create those chances to catch problems. If I were to, guess of one of those examples is maybe you've introduced a new dependency and it hasn't been through the ringer, if you will, on all the tests that have been thrown at it to make sure that those timeouts are correct. I think it does depend on the change. I would say if you are making changes like the one I just described, adding a new dependency, doing enough of this testing will build that instinct of, hey, before this goes live in production, we should make sure its timeouts are tuned. We should make sure that when it's unreachable, we have some graceful fallback or we have retries tuned efficiently. Those instincts will come as a result of doing this a ton. So I would say the thing I would suggest doing first is just getting into that cadence of regular testing, because that exposure to that testing, you will learn stuff, your team is going to learn stuff. And what follows from that is the instinct to say, I made a particular change. These exact tests or this exploratory test should be run before we say that this is production ready.
Perfect. And then we're getting close on time, so let's keep these last couple questions, see if we can fit a couple in. What are the top three tests for quick win?
All right, I would do the dependency test, dependency failure and latency. Those, regardless of what failures actually stem from, right? Let's say a dependency is having some sort of DNS issue or a scaling problem. For you, as the consumer of that dependency, usually that means it's either unreachable or it's slow. So I would start with your dependency test as a way to cover a lot of ground first, if you were to pick some to start with. And then I'd also plug our detected risks. Find ways to lint your system to look for those problems waiting to happen and use those to figure out what tests you should run next.
Excellent. And I have to say, we do have one more question that is probably way too much time for our minute or 30 seconds we have left. We will reach out to you. This one is about how the network failure injection works. Please reach out to us. We will reach out to you and answer that question. If anybody else has that question, we will go into that in detail but Phil will easily take 15, 30 minutes just on that question. But we are at time. Thank you very much, everyone, for attending. We are going to send out a takeaway, a playbook that goes over all of these things and how you go from setting up your first service to rolling it out across the rest of your teams. We'll be sending that to all of our registrants and attendees. Thank you very much for attending, and have a great day.
Thanks, folks.